Hello everyone, myself Hans. Today we are going to solve the problem of beta gamma function. Here in the question, show that integral limit is 0 to 2 x bracket 8 minus of x cube की whole power 1 by 3 dx is equal to 8 upon 9 gamma 1 by 3 into gamma 2 by 3. Either we have to prove 16 pi upon 9 root 3. Let's solve the problem. Given integral is this is given by I is equal to integral limit is 0 to 2 and x into 8 minus of x cube की whole power by 3 dx, and from here we can let x cube is equal to 2. Once again x cube is equal to 8 sin square theta. When we take x cube is equal to sin square theta, we get the formula when taking x 8 common, 1 minus of sin square theta, and from here we can also write that is x is equal to 2 sin 2 by 3 of theta, and further we have to find dx, that is dx is equal to 2 into differentiating sin 2 by 3 theta with respect to theta, this is 2 by of 3 and sin power minus of 1 by 3, and this is theta, and again sin theta differentiating with respect to theta, this is cos theta and d theta, and from here we can also replace, this is given by integral I, and we have to also change the limit. When we have to put here in place of x, when x is equal to 0, then theta is equal to 0, and when x is equal to 2, and from here that is when x is equal to 2, from here when x is equal to 2, then 2 cube is 8, 8 to 8 is cancel out, then theta is equal to pi by 2. So we have to write here the integral limit is 0 to pi by 2, and in place of x we have to write here that is 2 sin power 2 by 3 theta, and here 8 minus of, in place of x cube we have to let here 8 sin square theta, this is 8 sin square theta, and whole power 1 by 3, this is whole power 1 by 3, and in place of dx we have to write here this is 4 by 3 sin to the power minus 1 by 3 theta into cos theta, and this is d theta, and further we have to solve. This is integral I is equal to integral limit is 0 to pi by 2, and from here this is given by 4 by 3 into 2, this is 4 to the 8, this is 8 by 3, and sin the power 2 by 3 and sin the power minus 1 by 3. We have to add here, that is 2 by 3 minus of 1 by 3, this is given by 1 by 3. So we have to write here sin to the power 1 by 3 of theta, and from here we have to take common 8, and on the bracket we have to, once again we have to take common 8 from here, this is given by 1 minus of sin square theta, and whole power is 1 by 3, and remaining is here cos theta and d theta, and from here we have to 8 is taken outside, so 2 to the power of 1 by 3, 8 to the power 1 by 3 is 2, so we have to write here integral I is equal to integral limit is 0 to pi by 2, and from here we have to take 8 from bracket, this is given by 2, and 8 upon 3 into 2 is 16 upon 3, and this is given by sin to the power 1 by 3 into theta, and from here 1 minus of sin square theta. This is given by cos square theta, and cos square theta multiplying with 1 by 3. This is given by cos to the power 2 by 3 of theta, and cos theta is already present here. And further we have to write integral I is equal to, we have to take a 16 upon 3 is taken outside. This is given by 16 upon 3, and integral limit is 0 to pi by 2, and here sine 1 by 3 to the power theta, and from here sine 2 by 3 theta into cos theta is, we have to add here 2 by 3 plus of 1. This is given by 5 by 3. So we have to write cos to the power 5 by 3 theta and d theta, and further we have to use the formula. This is given by integral 0 to pi by 2 and sine power p theta into cos q theta d theta is equal to, given by gamma p plus 1 by 2 and gamma of q plus 1 by 2 and whole upon 2 gamma of p plus q plus 2 by 2. So we have to use this formula here. This is given by 16 upon 3, and we have to use this formula in place of p here. This is p is equal to 1 by 3 and q is equal to 5 by 3. So we have to put here in place of p, this is given by 1 by 3 plus of 1 by 2, this is gamma, and from another gram this is q plus 1 by 2, q is 5 by 3, this is 5 by 3 plus of 1 upon 2 and whole upon 2 gamma p plus q plus 2 by 2. Here p is 1 by 3 and q is 5 by 3 and plus of 2 upon 2, and further we have to solve. One second. Further we have to solve it. This is integral I is equal to 16 upon 3, and this is given by, when we have to solve here taking LCM, 3 1 is 3 and 3 plus 1 is 4, that is 4 by 3, and 4 by 3 upon 2 is gamma 4 upon 6, and from here 3 plus of taking LCM here, that is 3 1 is 3 plus 5 8 upon 3 upon 2, this is 8 upon 6 upon 2 gamma, one second, 2 gamma, here is taking LCM also, 3 is taking LCM here, that is, this is 6 plus 5 is 11 plus 1 is 12 upon 3 and 12 upon 3 upon 2, this is 12 upon 6, this is given by gamma 12 upon 6, and from here we have to cancel out 6 to the 12, and from here we can also cancel out, this is given by 2 4 is 8 and 2 3 is 6, and from here 2 to the 4 and 2 to the 6, and we can also write this is integral I is equal to 16 upon 3, and here is gamma of 2 by 3 and gamma of 4 by 3, and from here this is 2 gamma 2, and gamma 2 is written as gamma 1 plus of 1, this is given by n gamma n, using the formula gamma n plus 1 is given by n gamma n. So we have to write here 1 gamma n, so the value of gamma 2 is 1, so we have to put here in place of gamma 2 we have to write here 2 1, then this is given by 16 upon 3, and this is gamma 2 by 3 into gamma 4 by 3 upon, here is 2 into 1, and from here we have to cancel out 2 8 is 16, and this is given by integral I is equal to 8 upon 3, and this is given by gamma of 2 by 3 into gamma of 4 by 3, and gamma of 4 by 3 is also written as, using the formula, this is gamma n plus 1 is n gamma n, so we have to write here gamma 4 by 3 in terms of, this is gamma 1 by 3 plus of 1, we can write gamma 1 plus of 1 by 3. This is given by 8 upon 3, and gamma 2 by 3 into, we can write gamma 4 by 3 in the form of gamma 1 by 3 plus of 1, and we can write gamma n plus 1. This is given by n gamma n, so we have to write integral I is equal to 8 upon 3, once again 8 upon 3, and this is gamma 2 by 3, and we can write here, and gamma n plus 1 is n gamma n, so we have to write 1 by 3 gamma 1 by 3, and from here we can also write, this is given by 1 by 3 into 8 by 3, this is 8 by 9, and this is given by gamma of 1 by 3 into gamma of 2 by 3. We have to prove the first part, and we have to further prove 16 pi upon 9 root 3. So we have to, using again another formula, this is given by gamma of 1 minus n, and gamma n is equal to pi upon sine n pi. So we have to write here, this is 8 upon 9, and gamma of 1 by 3, and gamma of 2 by 3 is written as 1 minus of 1 by 3. 1 minus 1 by 3. We have to take LCM. This gives 2 by 3. And using the formula, this is gamma. We can also write in the form of, this is gamma n and gamma of 1 minus n. Nothing to effect. This is gamma n 1 by 3. This is gamma 1 minus n, and gamma n is written as pi upon sine n pi. So we have to write here, this is integral 8 upon 9, and in place of gamma 1 by 3 and gamma 1 minus 1 by 3 is written as pi upon sine. In place of n we have to write here 1 by 3, this is pi by 3, and we know that this is given by sine 60, and the sine 60 value is 180 plus of 3, this is sine 60. Sine 60 value is root 3 by 2. Sine 60 value, once again we have to write here, the value of sine 60 is given by sine 60, this is given by root 3 by 2. Root 3 by 2. So we have to put here, this is given by 8 pi upon 9, and we have to write here, once again this is given by pi upon sine 60 value is root 3 by 2, and we can also write, this is given by 8 upon 9 into pi into of 2 upon root 3, and this is given by integral I is equal to, here is 8 to the 16, this is given by 16 pi upon 9 root 3, 9, once again this is root 3, so we have to write 9 root 3, and this is the another proof, and this is the required solution of the given problem. Thank you class, and thank you for watching. If any doubt, kindly ask in comment section.